Welcome back to another Daishinfinity video. In this video, we're going to talk about the derivative of the function cosine of x. Cosine of x is a function known in trigonometry, and in this video, I would like to prove the formula that the derivative of cosine of x is the same thing as the negative of sine of x. So I'm going to prove this formula right now. We all know that the limit definition of a derivative f prime of x is the same thing as d divided by dx of f of x, which is also the same thing as the limit as h approaches 0 of f of x plus h minus f of x and the whole thing over h. Now, since we have this limit definition, let's use this limit definition in order to prove the formula. So let's use cosine of x and plug the cosine of x into the functions. So we will have the limit as h approaches 0 of cosine of x plus h minus cosine of x and the whole thing over h. Now, what is cosine of x plus h? Now, we know from trigonometry that one property says that cosine of a plus b is the same thing as cosine of a, cosine of b, minus sine of a, sine of b. This concludes that we can write this x plus h as another way. So we will have the limit as h approaches 0 of cosine of x, cosine of h, minus sine of x, sine of h, all over minus cosine of x, all over h. I hope you understand the s. It's a bit messy over there. Now we're going to find like terms. So cosine of x, we find it twice, and sine of x, we only find it once. So we're going to group cosine of x, cosine of h, and cosine of x all together in one, so that we can factor the cosine of x out of it. So we will have the limit as h approaches 0 of cosine of x and the whole thing times cosine of h minus 1 over h. And we all minus sine of x, and we factor sine of x out of the sine of x, sine of h over h. So we will have sine of h over h. Now, a property of a limit says that the limit as x approaches any number a of f of x plus g of x is the same thing as the limit as x approaches a of f of x plus the independent limit as x approaches a of g of x. Since we can split those addition or subtractions, we can both do this for the limit we are looking for. So indeed, we are going to get the limit as h approaches 0 of cosine of x times cosine of h minus 1 over h minus the limit. We are going to put the minus out because minus 1 is just a constant, and we have sine of x times sine h over h. Now, since cosine of x and sine of x are functions independent of h, from the perspective of the variable h, cosine of x and sine of x, no matter what x is just a constant. So we will just have cosine of x and then the limit as h approaches 0 of cosine of h minus 1 over h, and we all minus the sine of x times the limit as h approaches 0 of sine of h all over h. Now, if we look at the limits, then we have to calculate the limits in order to get the answer. But I have already calculated this limit in a specific video where I proved that the derivative of a function sine of x is equal to cosine of x, which means this limit is already proven by me. So just watch the video if you would like to see it in precise or detail. So the value of those two limits, especially the limit as h approaches 0 of sine of h over h, is one of the most important limits you have to learn in calculus, which is going to be 1. And the limit as cosine h approaches 0 of cosine of h minus 1 over h is equal to 0, which means we have cosine of x times 0 minus sine of x times 1. Cosine of x times 0 is 0, so we will just have minus sine of x. So we have proven this formula. I hope you like this video. Please like and subscribe and follow for more videos, and we'll see us in the next Daishinfinity video. See ya.